Let's take a look at bandwidth and connections and how we measure these. All right, in talking about measurements, there's a couple things that I need to make sure that we're clear on, and there's some misconceptions I want to make sure we clean up here first. So we're going to talk about a bit versus byte. We're also going to talk about the measurement of kilobits, megabits, gigabits, and terabits, and specifically how it relates to bits per second. And then we're going to talk about connection measurements and get into how do we judge what makes a good internet connection or what makes a good networking connection. All right, first let's clear up a misconception here. So most of us are probably familiar with a bit, which is just a single 1 or 0. And we're probably familiar with a byte, a series of 1s and 0s, or specifically 8 bits. A byte is 8 bits, so we're probably familiar with that. The way we represent this when we label things with abbreviations is a bit is a little b and a byte is a big B. So the misconception that I want to clear up is that storage is usually measured in bytes versus speeds of connection are usually measured in bits. Let me give you an example of that. If you have a connection, we measure that. Maybe you have a connection to the internet that's 100 megabits per second. So that's capital M, lowercase bps. Versus your storage, when you get storage, you're probably getting something like 500 gigabytes of data. So generally we measure our speeds in bits and we measure our storage in bytes. So just wanted to clear that up to make sure that we're on the same page there. So another way of stating this is right here I have 8 bits, and so if I measure this, let's say I transferred 8 bits across a line in 1 second, then this would be right here 8 bits per second, which would be an incredibly low speed. We hopefully at this point in time don't have a connection that is 8 bits per second. We're communicating at a much faster rate, but this just puts it in perspective that it's bits per second. Of course, our speeds are much faster, so we generally measure things in kilobits per second, megabits per second, gigabits per second, and sometimes terabits per second. So then we get into our original question again, what makes a good internet connection? And probably the immediate thing that pops into our mind is, well, bandwidth. But there are more than just that as a measurement of how good a connection is. And so let's go through some of those measurements of how we would measure what makes a good connection. One of the big ones is uptime. And so if our internet connection is constantly going down, that's going to be a big problem, especially in our businesses. So I'd say one of the big ones is just uptime. The one we're probably most familiar with is just bandwidth and how much bandwidth we have, how much bits per second we can get through a line. Although strictly speaking, that is a good measurement, there is also some consideration that we have to have for overhead. And that is that different types of technologies will require a different amount of overhead or different signaling bits and different things that go across the line as well that take away from the main bandwidth that we actually have to utilize. So we have a couple more specific measurements that we have to consider, not just bandwidth. So what are some of these measurements that we have to think about? Well, overhead would be the header, the footer, the data that goes across for signaling, for all of this extra stuff. So when we're talking about bandwidth, the bandwidth is the connection, what the connection total can handle. So for instance, maybe this connection right here that we have right here can handle a total of 64 kilobits per second. So that's what that line is capable of handling. So then we have some signaling that happens with this line right here. And so the line has to maintain a certain level of connectivity, and maybe there's it's a phone line or something that uses up some of the signaling capability. And let's use an example of 8 kilobits per second for that. So when we subtract the 8 kilobits per second, then we come up with 56 kilobits per second. And that is how much throughput we have. The throughput is what is available for the devices to communicate back and forth. So that could be significantly different than the overall bandwidth we have. So we've got the throughput, which is what the devices can communicate back and forth through. Then we also have goodput. The goodput now it takes into consideration not all data that we send across to this other device is going to be good. Let's say we've been sending 56 kilobits per second, but half of it gets over there and it's not great data, and that data has to be resent. Well, now you're going to have to take that in consideration. So maybe our actual throughput right here is maybe it is 26 kilobits per second that we actually have that can make it through this connection right here. So you got to take in consideration things like signaling and traffic that has to be resent, and those type of situations that we have here also, because it could severely hinder actually your connection speed. And it's not measured purely by strictly bandwidth. Another one of those measurements is delay and latency, something that gamers are really familiar with, because delay and latency can cause real problems when you're talking about games like first-person shooters. So delay would be, if I have a message here, maybe I have a series of ones and zeros that are being sent, the delay would be how long it takes from the time this device sends out this message to the time that this device receives the message. That would be delay, versus latency would be how long the full message it takes for the full message to get over to the other side. So that's delay and latency, very similar in how it manifests itself on your network, but those are two measurements that you'd want to be concerned with as well. Jitter is yet another measurement, and jitter can be really detrimental, not just to gaming, but things like video and audio conferencing. And so jitter is how consistent the data is coming across the line. There can be a little delay with video as it goes across the line, but if it's coming in inconsistently, so maybe you get a burst of some of the information and then there's this long gap of no information and another burst of information, then that can cause a problem as you're making a connection with these video conferencing. And that's where we get some digitization of the image, or it kind of sounds really garbled as it comes across, the audio comes across. So jitter is that consistency with the data that's being sent across the line. So another measurement that you may not be familiar with is bursting. So a lot of our connections have this limit of what speeds can be sent across these connections. But there are some type of connections that will allow us to go above that, and that's called bursting. So a lot of our traffic, when we initiate a connection, a network connection, sometimes we need a big chunk of data, and then it takes a little bit of data to maintain. For instance, video conferencing. When we initiate a video conference, we need a lot of information up front to establish that connection and that image and the sound, but then the amount of data tapers and is not as great to maintain that connection. So some of our internet service providers allow us to do bursting, which goes above what our connection speed allows us, or is what we purchased, and it allows us to go above that for a certain duration. So there's a volume, how much above that we can go, and for how long we can go for. So that's bursting, and a lot of our connections will allow a certain amount of bursting. Getting back to our bandwidth and throughput and goodput, I'm going to bring it back to communication errors. There are things that happen like collisions on our networks, or there's some sort of errors. There's things that will happen on our network that will bring down the quality and allow us not to get our full bandwidth. And it may or may not be a fault of the connection. So communication errors is a problem as well. So that's another thing that we have to consider when we are evaluating a connection.